In this video, we will learn how to calculate Lerner's index with an example. The question is, the demand function for a good is given by Q is equal to 4 upon P cube. Q denotes the quantity demanded and P is the price. And the firm's marginal cost is $5. Find firm's Lerner's index and profit maximizing price. We need to calculate the Lerner index and profit maximizing price. Okay, so by Lerner index, what we mean, Lerner index measures the percentage markup that a firm is able to charge over its marginal cost. It is a measure of the monopoly power, and monopoly power is given by the difference between the price and marginal cost at profit maximizing level. And it is given by Lerner's index is given by, let's denote it by L. It is being given by price minus marginal cost upon price, which is equal to 1 upon the elasticity of demand, price elasticity of demand. This relation shows us the Lerner's index. Okay, so that means we need to calculate first the price elasticity of demand. Okay, marginal cost is being given us here. So let's first calculate the elasticity of demand for the given demand function, price elasticity of demand. And we know we have this demand function, and let me first write the given demand function, which is Q is equal to 4. This p to the power cube, I can write it in this fashion, p to the power minus 3. If I transpose this to the numerator, the exponent sign will change. Now to calculate the elasticity of demand, we know the formula is simply the change in the quantity demanded due to the change in price upon quantity demanded. So first we need to calculate this dq upon dp. Okay, so dq upon dp means we take the derivative of the given demand function with respect to price. Okay, here we have 4. Derivative of p to the power minus 3 is simply minus 3 p to the power minus 3 minus 1. By power function rule, if we have x to the power n, its derivative is n x to the power n minus 1. I have explained it at number of times. Okay, so that gives us dq upon dp is equal to, so here it is minus 4 into 3 is minus 12, p to the power minus 3 and minus 1 is minus 4. This is our dq upon dp. Now what is elasticity of demand? Simply dq upon dp is what we calculated as minus 12 upon p to the power, rather minus 12 into p to the power minus 4, p upon q into p upon q. Q is this function 4 p to the power minus 3. So we will get elasticity of demand first as, if I transpose this p to the power upon 3 to numerator, it will get added with this p. Okay, so it will get multiplied, but exponent sign will change. So we will get here minus 12. Transpose this to the denominator, it will become p to the power plus 4. And here we have p into p to the power plus 3. If I transpose this to the numerator, and here we have 4. So we will get elasticity of demand equal to 4 ones are 4 threes are, which is minus 3. Minus 3, we will get p to the power 4 upon p to the power 4, which implies our elasticity of demand will be equal to minus 3, and absolute elasticity of demand will be equal to the absolute value of minus 3, which is equal to 3. So we got this elasticity of demand equal to 3 for the given demand function. Now the Lerner's index, as we know, Lerner's index is given by this way relationship. So we have price minus marginal. Okay, let's first calculate the Lerner's index here. Okay, Lerner's index is equal to 1 upon the elasticity of demand. Okay, so we will get 1 divided by the absolute value of elasticity of demand, that is 3. So we got, and let me write it here, that means our Lerner's index is equal to 1 upon 3. Okay, so we got the Lerner's index. Now we need to calculate the profit maximizing price. So we know this relationship must hold here. and it is being given by, so P minus marginal cost is being given as is minus 5, rather plus 5 upon P. It should be equal to this 1 upon the elasticity of demand which we calculated, which is in fact equal to 1 upon 3. Okay, so solving this equation will give us the profit maximizing price. So we have 3 into P is 3P minus 15 is equal to P. Solving for P, so 3P minus P is 3P. Transposing it will get subtracted. Transpose this to RHS, it will become plus 15. So we will get 2P is equal to 15, or P will be equal to 15 upon 2. That means profit maximizing price will be equal to 7.5. Okay, so this is how do we calculate the Lerner's index and the profit maximizing price. The relationship between Lerner's index and elasticity of demand is negative. Okay, the more the elastic is the demand curve, the less will be the Lerner's index, and the less the demand curve is elastic, the more will be the Lerner's index. Okay, and by Lerner's index, it simply measures the percentage markup that a firm is able to charge over its price. I hope I make myself clear in this video. And in case of perfect competition, here you can see uh, when we have perfect competition and we know price is equal to marginal cost in case of perfect competition. So what will be the Lerner's index? Lerner's index will be equal to, so P minus MC. So if I solve this P minus MC, it will become P minus MC is equal to 0 if I solve this equation. So we will have 0 upon P. That means Lerner's index in case of perfect competition will be equal to 0. Okay, I hope I make myself clear in this video. So this is absolutely not the case of the perfect competition. It is a kind of monopoly where we have some sort of Lerner's index, and which defines the monopoly power of a firm.